Hello, everyone. Thank you very much for coming. Today's talk is about an open source language called C Natural. So we'll get into the language and everything in just a second. First, we'll talk a little bit about how the session is going to be set up. So we set the talk up so it'll be roughly 15-minute introduction, followed by a hands-on tutorial led by Alice. These slides and all of our contact details will be available at the tutorial repo down there, gitlab.com/cnatural/demo, and in the following slides. So if there's any follow-up, please get in contact. Additionally, please ask questions throughout. No questions too big, no questions too small. Please just let us know what's on your mind. So then, who are we? I'm Matt. I'm a third-year undergraduate computer science student. I've realized while we were doing this that write lots of C++ languages is a little bit undermining. So I have written in big industry code bases before, written very, very old C++. I've written very, very modern C++. Some of my code is in big institutions. I have worked with teams on big C++ code bases. I've read a lot of languages. And in the one time that we have been graded on writing C++ at university, I got 100 out of 100 marks for the implementation. So I think I'm maybe a 3 out of 10, but I do know how to write C++. Alice.
Yeah, I have slightly more official C++ credentials. So I am a third-year student, technically a fourth-year student if you include my placement year. I did a placement as a software developer at Sophos, and then later on I was a test automation engineer also at Sophos. The majority of the code that I wrote at Sophos was in C++, so I spent a very long time writing a lot of C++ in a lot of different contexts, and also a lot of Python, but we don't care about Python today. And my emails, if you ever need to contact me, are down the bottom.
We care about Python a little bit. We'll see how that translated to C Natural a little bit. So before we start, big thank you to all of the original folks that got this language kicked off. Big thanks to Charles Fox for being absolutely magnificent supervisor. Big thanks to Kieran for getting everything all nice and smooth and setting everything up for us. And a big thanks to you for giving your time to us today, I guess. I was going to say for coming out today, but I thought that would be a bit mean. Let's see that. So, on to C Natural itself. This is the most important quote to keep in mind throughout the talk. This is from C++ creator Jan Strostrup. He has said many times that within C++, there is a much smaller and cleaner language struggling to get out. So this quote gets talked about a lot, but the specific context for this quote is that C++'s semantics is much cleaner than C++'s syntax. So in other words, the logic behind how ideas are expressed is much cleaner than the combinations of characters that developers are actually using to type them out, how they're actually getting those ideas across. So what is C Natural? How does it fit into this goal? In a sentence, C Natural is C++ minus redundant syntax. Again, it's just syntax. It's just the way that things are written, not so much changing the form of the ideas being written. The theory is that C++ is a good language. It is provably good. We'll get onto that in a moment. But people are complaining about it non-stop at all levels of learning. Beginners to hardcore developers, people who actually work on implementing the language probably have the most to say about it. So C Natural is trying to begin removing things a developer has to type that do not convey new information about the program. That's what it means by removing syntactic redundancy. So if we're going to explain how C Natural ties into this, we'll start with a little bit of C++. Regardless of your exposure to C++, C++ is the backbone of an enormous number of applications. Browsers, everything made using browsers, operating systems, embedded devices, and a lot of other languages rely on C++ and libraries written in C++. For example, most machine learning applications rely on it through a lot of libraries like TensorFlow and PyTorch, but everyone wants to use the wrappers built around these C++ code bases to use them with other language. No one really wants to write in C++. So here, I'd like to make a distinction between a good language and a language that people enjoy writing. Now, coming back to that quote by Strustrup, C++ has perfectly good semantics. It has powerful touches. The way that you express ideas are really, really powerful, but that's not the whole story. The syntax could do with some work, even down to very, very simple things that we can change right now. If you compare C++ to other modern languages, even other C-based syntaxes, it's very, very verbose, and a lot of that verbosity doesn't actually come from the expressions themselves, but the things around them. So we have a short list, but headers especially, duplicating all of your declarations and how things are laid out is not something that you see in other modern languages because they've been done away with. We can get onto that in a sec if we want. Now, if you ask C++ developers what should change, you will get 1,000 different answers depending on what gripes people have. So CNatural is going to start with very, very small steps. Less toes are going to be stepped on, hopefully, and we're not trying to be something other than C++ because we think that C++ is a good language. It's a good language. It's a powerful language. It's pervasive. It's sticky. It's everywhere. So it does mean that the changes that CNatural makes, in theory, are a lot smaller than the changes that other languages that are based on C++ make. But with the advantage that developers have all of C++ at their disposal, and it's just C++. Again, there are a lot more changes that could be made, a lot more lines that could be drawn, but like not yet. So that's why CNatural exists. How does CNatural actually achieve this? So the first, most important goal of CNatural is that it is C++. We're not trying to do something other than C++. We think that C++ is a good language. Again, one of the big problems, actually, with languages based on C++ is that they become not C++. Everyone is using C++. A huge ecosystem is based around C++. And you have to be very, very careful about taking small steps and not large strides unless you are aiming to do something quite different from what C++ is achieving, which is, a perfectly valid goal. But C++ is doing what it does very, very well. So what makes or breaks a language isn't the language itself, though. It's the tooling and the existing support. And C++ is almost 40 years old and everywhere. So it has lots of tooling, lots of existing support. Syntax highlighters, debuggers, memory checkers, liders, etc. And I'll also go back on these in just a moment and how they actually fit into CNatural. But people rely on these existing pipelines. So let's not toss out the baby with the bathwater and still stick with C++ as the core of what we're doing. So here is what a sample program might look like. Well, does look like in CNatural. This is some code that I've written before. So we're using, people might note that we're at the top, we're using namespace std. That's just anyone who's not so familiar with C++ that might ease you in a little bit. We'll not get into the specifics of that. But the first thing to note is this is all implementation and there are no headers. Now, of course, you can just write implementation code in C++ and it will compile. What are we saying is different? Well, we get all of the benefits of header files without needing to write them separately from our implementation. So, for example, we could move those protected variables down to the bottom, and we would expect everything to still compile just fine. And we can link to other C++ files without needing, that header as an in-between, as a glue. So one thing that a lot of people bring up as an argument when you say you want to get rid of headers is that headers allow you to see and interact with, well, just the interface, just the declarations on the top. Well, as you can see here, in our code editor, we have folded a lot of lines so that we don't have to read them. You don't need a separate file to be able to just interact with headers and the declarations and the information that you want to be doing, even for large refactors and stuff. You just fold them. Yeah, of course. Also, you'll also notice that there are no semicolons, there are no curly brackets. You will also notice that there have been no loss in readability or no loss in meaning from this program, because they're not necessarily adding anything extra to the syntax. They're just additional. So that's why it's there as a feature. If we're removing redundant features, it's an easy place to start. So the cost of doing literally anything to something as massive and as old as C++ is that there are 1,000 exceptions, edge cases, and syntactic complexity, because it's a very, very, very old language. They've changed ideas about how a language should be laid out over the 40 years that C++ has been around. So even a relatively small feature set, like what we've just shown, has quite a high cost associated with it. I haven't talked too much about the implementation that exists for it, exists for CNatural at the moment, the CN compiler. But if the feature set seems quite small, again, small steps before big steps when you're working on something as massive and complex as C++. So the last thing I want to mention before I pass you on to Alice is we would like more opinions about this. Anything you think doesn't need to be in C++, should be in C++, is good or bad about CNatural as a language, please open issue on GitLab, send us an email, just let us know what your opinions are, and hopefully we can make CNatural into a tool that helps folks write better C++. Super. Right then, Alice, on to you.
Yeah, I would just like to add something real quick, that if you do also have any usability features that you do want added, if you could also let us know, because currently all the usability features that have been added are mostly to make my life easier. But my programming style will not be the same as anyone else's programming style. I mean, Matt and I already have very different programming styles. So currently, everything that exists is for me. But of course, I would like to make this a language that other people want to use instead of have to use. So the more you could help us out, the better. So there will be a tutorial. This tutorial does only work on Ubuntu 18 and 20, or it has only been tested on Ubuntu 18 and 20. If you have a different Linux distro, then by all means try it out, see how far you get, and please let us know if you come across any bugs. Windows users in the chat, I'm sorry, you're not included right now. That's a very difficult task for the future, but unfortunately we cannot do it now. So if you would like to look at the code, there is a demo repo that we have set up specifically for the demo. So that includes the presentations, the current stable release, and all the usability tools and some code snippets just to kind of help you out. So before I actually show you some code and we program and we look through it together, there are some things that you cannot do. For example, multiple classes in one file, you can sometimes do that, you sometimes can't. This is something we would like to work out. So multiple files you can use, but I only sorted it last night, so there may be some problems. Again, I will demonstrate how you use multiple files and how you may want to do that in the future. Enums, we think you can now use them, but just in case you can't, we've kept that in, but we're pretty sure you can now use them. Templates as well, you can't really use them right now. And multi-line statements, we do not have support on. That was one of the first things I noticed when I started writing CNatural. I tried to have a multi-line statement and I spent an hour trying to work out what my problem was. But you cannot have them just because of the way the compiler is made. And again, it only works on Linux and is only tested on Ubuntu 18 and 20. Just quickly, so we do have a question. Matt, do you want to answer that now or later?
That is a magnificent question. So there is actually a specific definition in languages for what is and is not redundant, but it still falls under opinion. This is one of the problems with making changes to something like C++. And why? So with CNatural, we're not making any changes to expressions themselves. Every expression in C natural is a valid C++ expression. That means that because we have all of the actual text at the moment still, there's no difference in what is and isn't like added in terms of functionality. Now, obviously, the implementation that we have at the moment is still a work in progress, as Alice just mentioned. But in terms of what is and isn't removing redundancy, you look at what changes semantic meaning. So that's the difference between syntax and semantics. So if there's a change in how ideas need to be expressed in the language, that means that we haven't necessarily removed something that's redundant and is just a piece of syntax that may or may not be helpful. Whereas if I remove something along the lines of curly brackets are a good example, you're probably going to add indentation anyway. So if I'm looking at a bunch of files and they all have indentation as information about how the scopes are laid out within the program, then curly brackets are just additional information that the compiler needs, but the developer doesn't necessarily need as they're adding and talking about how scopes are laid out within a program.
Okay, sweet. So whilst Matt was talking, I did put the prerequisites up. Currently, there are quite a lot, so there are essential and there are optional. I figured I would put that up earlier just in case anyone is doing this from home. There may be some things that you need. So CMake, all of the scripts, the install script especially, does need CMake and make in order to run it. Though after you've done that, they are not essential, but they are useful. G++, obviously, it's a C++ based language, so you need to be able to compile C++. Flex and Bison are two things that I don't think most people have heard of. They're very specific for kind of language design kind of things. And they are the lexer and parser, so that is how you build and run our C natural code. And then for this tutorial only, there is SDL2 and SDL2 image. The tutorial will be going over how I made the world's most basic Space Invaders game. And for that, you do need some kind of graphics or graphics package. I'm using SDL2. Other packages are available. Git, useful. Most people probably already have it. You really just need Git to download it, but again, there is a download button where you can just download a zip file if you don't want to install Git just for this. And then VS Code, again, not essential, but the LSP language server protocol that I have created is only currently available on the VS Code store, which I can show you now. So this is a language server protocol. This is the VS Code store page for it. And essentially, it is usability features on the IDE. So an LSP, for those who don't know what it is, since I didn't until 6 months ago, it is a simplified way so that you can get all of your features on all of the IDEs by only creating one thing. So an old method was you may want to create a syntax highlighter and then you'd have to create it for all the different IDEs. Microsoft have very kindly invented a software where you can create one extension software and then you can then run that on any IDE you wish. We have not ported it over. There are a few changes I still need to make to be able to port it, but it will be ported to Vim and some other editors that I can think of in the future. If anyone has a preference for an editor that's not Vim or VS Code, please let me know. So current features on here, there is a syntax highlighter. Most of the syntax is highlighted in C++. Obviously, writing all of the C++ syntax would take a very long time, so there may be some I have missed off. I have also added some syntax that is C natural only. I think there might only be one C natural only syntax, which we will talk about in the future. So there is a hover function that you can hover, but it doesn't do anything, but I've included that in the README. There is a logging system which is for my benefit, not yours, but it's on the system right now, just in case. And this is where we get to the list of things that are really for my benefit and my benefit only. Tab warning notification. Because Natural works using tabs, it's very reliant on your indentation level. So my big problem is when I comment outlines of code, sometimes I forget that I also then need to re-indent it. So I added a notification thing just for me. It does only work quite simply right now, but in the future it will be expanded. Again, everything I do is for my usability, so things may not work for you. There is also local autocomplete. So as long as the function you are trying to autocomplete is on the same file that you are currently working on, it will autocomplete. Unfortunately, it won't autocomplete for any functions on separate files or any built-in C++ functions or other files, but that will happen in the future. And then near future features, Vim and other IDE and editor compatibility, and I will be making a semantic highlighter, because as you will see, there are some things that aren't so nice to look at. So that is the extension. I have described it now because hopefully you won't notice that it's an extension that I built when we look at the VS Code. That's the hope. There are some obvious standouts to me, but who knows. And then I just have the demo repo. So if you do want it, everything you need is up here. If you want to follow on or do this another day, please take this repo and play with it all you want. Yeah, so if I get VS Code up, hopefully this is at a good level for everyone to see. So this would not be a tutorial if we did not have Hello World written out. This is a slightly, oh no, this is a simple version. This one is for the debugger. I do have a slightly more complex version where we call onto a secondary file to do Hello World. But I'm getting ahead of myself. We need to install CNatural right now. So there is no such thing as CNatural on my PC. But if I type these commands in, essentially compile the CMake, run the make, and then install the make file. And then if I run this and see if it asks for my password, and then, yep, it will. And now it has installed. So you will see if I run CNatural, no arguments are given. And if I run CNatural-help, then you can see kind of the help file for CNatural. So we can see it is now installed, and we can leave this repo and still type CN. It's global. You can do it wherever you want. I will apologize for my keyboard if the noise bugs you. I don't know how to type on a different keyboard. So now we have installed CNatural. How do you actually run a CNatural file? Password for Yeet. Yes, thank you. I needed to give my virtual machine a name. The password's password. So we have a utilities folder. This utilities folder contains the compile script and the debugger. So theoretically, everything you will need to create a proper program and create some fully working CNatural code. So if this CMake file, we do not have the install, but you can see how difficult it is to read code in just black and white. That's why we have a syntax highlighter, as you can see. So this compiles CNatural, and then it compiles the C++ and gives an executable. Some additions on this CMake file that make it so you would probably want to use it, especially for something like SDL, is this bit. I'm not expecting you to read and understand it. I will explain it. So there is a new thing called ImportLib. I will show you how to work that later on. But it means that instead of linking all of your libraries manually, you can just add the ImportLib keyword to the top of a CNatural file, and it will automatically link every single library you will ever want to use. You do specify the library, so it does work very well. Unfortunately, you do still need to add the headers. There are so many external libraries that I'm not going to write all of the headers and link it to all of the libraries. It's just a lot easier if we just have this ImportLib flag that links the libraries, and then everything from then onwards is almost identical to how you would write C++ with a different syntax. And no header files, obviously. So, in order to run it, it's cmake dot, but we need, the dot just means in this directory, and then we need to add a flag. So the cmake needs to know what file we're trying to compile first. So currently that variable is called cmake input file, and we want to add test. It is up to you if you want to add the extension. The extension is not essential at all. You can add the CN, you cannot add the CN, up to you. This hello world is slightly more complicated in the fact that I've used an external file for it just to demonstrate that. So the include for the second file is 2.hpp. Unfortunately, it's not 2.cnatural. I would like to make that change in the future, but for now, linking the header file when the C++ is compiled works. And the cmake file will go through all of the includes and look for any include for a header file and then link it automatically for us. So we do not have to worry about making sure we link anything else. So cmake, and then we run make, and now you can see that has built the target test. And then if I run test, it will print hello world, and we have made our first hello world program. CNatural is an official language at this point. So I'm just going to leave that directory and quickly show you how the debugger works. So again, we have the cmake compile, and close that down, and the test.cn file. So the debugger, we kind of had two choices. We could build a debugger from scratch, but that takes a lot of time and effort and energy, and it would never be as good as the C++ debugger that already exists. So we are tricking the debugger into thinking that CNatural is C++. Essentially, with just renaming the file to give it a C++ extension, and then we're calling the debugger. And it works. So if we do have to compile the cmake file first, which I will really quickly do. Cmake input file equals test and make. And now that has made the file. We can run this as test. But imagine if I put a mistake somewhere in this very simple hello world script. We may want to find out where that mistake is and debug it. So to do that, we would want to do gdbn, which is this file right here. And now if we run it, you can see this, anyone who's familiar with the debugger can see it's just opened GDB. So we have a debugger, great. How do we use it? Exactly the same as you would use it in any other method. So you want to get all the symbols from the test, and then you want to put a break on, well, you can either put a break for a line number, or you can even put a break for the function. So I have a function, it is called f. And if I add that, you can see it's put a breakpoint on line 4. Lovely. So now if we run that, it's broken at line 4. Exactly what we wanted it to do. And then if I continue, you can see it's printed hello world and exited normally. Exactly what we expect it to do. And then if I quit the debugger, all of the files go back to normal and we pretend it never happened. So everything works exactly the same way you debug C++. If you need to know more about the GDB debugger, there are websites online that can help you. There are tutorials, but we have tried to keep it as similar to how you would use C++ as possible. Obviously with any usability features that I personally would like to add. So now we can get on with Space Invaders. I will point out all of these code snippets are pre-written. I do not trust myself to write code live. No one writing code live, it's always a bit of a danger area. So I hope you will forgive me for not actually writing the code. So again, I have everything I need in this file. I have the CMake list file, I have some test programs, and then I have each stage that I am about to discuss. So firstly, the background. This very simply does what it says on the tin. It makes the background for the Space Invaders game that we are going to make. I've also included some very basic images, just if you do want to make this at home, it's very easy to do yourself. So this is the first example where you will see the ImportLib. This is why I need a semantic highlighter, because ImportLib should not be two separate colors. And then, as you can see, you use ImportLib almost the same as you use include. This is the library I want to link, and this is the header file that I'm going to use in the C++ code. This ImportLib will not break the C++. It will not get moved over to the C++ file. So C++ will never see it as an error. It is exclusive to C natural. And it does make it a lot more usable. Again, it's not essential for you to use this. If you do want to link all of your libraries yourself, feel free to do so. That's completely your choice, but it does make life so much easier. I have copied over all of the private variables that I'm going to use just to make life easier. So kind of the basics, what you expect, the windows, the renderer, the textures, and then just some basic integers at the bottom. And then we move on to the actual code. So we've got Space Invaders, we've called Space Invaders as part of the LSP. If I want to call animation loop, I can. And that is exactly what we want. And then we add the brackets to make it valid. So first thing, we've got a constructor to create the window, create the renderer, and then a destructor to destroy everything properly. Then we have an animation loop. This currently contains nothing because there is no animation, but it is something we will be using in the future. And for now, we do need the screen to clear and re-render every iteration, just so that the black background does not disappear immediately. I would actually like to show this to people. I'm just going to copy the command I used earlier and just add the background, and that works. Background command is not found. That's because I didn't add --. Programming live, yay. And now you can see we have a very simple basis to any game you ever want to create. A black background of a random size. And that's it. That's incredibly boring. So let's move on to adding something a little bit more exciting. Add the little sprite character. So we've got almost exactly the same stuff here. We have a create texture function that I have added, which creates any texture that you input. This will be reused in the future for the monsters and the bullet. We are also adding another destroy, so we destroy the texture when we destruct it. And when we construct it, we are adding the create texture. My coworker has left. And then we have sizes for the control, just to set out random sizes. These are completely arbitrary. You pick the size you want. This just works for me. So I have now added some stuff to this animation loop. So I have added key controls. You can move left and right. The little monster alien spaceship thing that you move only moves left and right. In Space Invaders, you never move up and down. So I haven't added that. But you can, as you can see, this is all almost identical to C++ code. The statements are all very nicely indented just to make it very, very obvious. And then we are clearing and copying everything at the end. So if I rerun this, and it is called Sprite, so I will rerun this command with the Sprite function. And now you can see there is a red square that I can move left and I can move it right. Very impressive. I know everyone's so excited to see this square. But that is kind of the basics of Space Invaders. You got a square and it moves. I'm very unimaginative with my color scheming. I'm not a graphic designer. I did graphically design the logo, however. So the next thing you need to make this game slightly more interesting, monsters. Again, we've got the texture. We just need to destroy all the monsters in a little loop. This loop will keep appearing. We use the loop to create, we use the loop to destroy, and we use the loop to re-render. We then also use it to check the boundaries so the monsters can't go outside of the screen, and to move them left or right, whichever direction we're choosing. And then if I run this, there should be some more monsters on the screen doing what I like to refer to as a little dance. Because this is a very simple program. This is not, you would not pay money to use an arcade machine that looked like this, but it does the job. You can tell they're monsters. You can just about tell this is supposed to be Space Invaders, but it's not really a game at the minute. You cannot do anything. This is all it is right now. So if I just quit that, the final thing we need to add is the bullet. This is the part where I had to use the debugger the most. Unfortunately, there was not a debugger when I first wrote this 7 months ago. I had to just use the C++ debugger. That was my choice, and that was kind of what made us want to make a debugger as a whole. So we just add a shoot function, which creates the bullet texture. In the animation loop, we move the bullet every single time. If it doesn't exist, it doesn't exist. The bullet hits the top of the screen, it gets destroyed. We have a little collision check, so if it comes into contact with one of the monsters, the monster disappears or dies, and there is a very simple scoring system. Essentially, when you get to 10, the game just quits. Again, this is very simple. Please make a better version yourself. I would love to see someone create a real marketable Space Invaders game in C Natural. But this is just a test program that we use. It shows off the capability. It's something that you can actually make and something you can actually use. And there are not a lot of bugs in it, even better. So you can't really see the little blue bullet, but you can see the disappearance. And you can see them disappear. Unfortunately, I don't know how to make it any bigger, but it's also a very easy game. Anyone can do that. Anyone can play this. Anyone can do it. And that is essentially C Natural. That is almost everything I think you would need to know to start writing in C Natural. Very quickly going to demonstrate my usability tab complete. As you can see, the tab is not 4, so we get a warning. Tab is 3, you get a warning. 4, and the warning completely disappears. So that is C Natural. That is how you use C Natural. That is how you code in C Natural. Almost everything I can think of that you may need is there and exists. There are some bugs and improvements, and if you have been looking at the code or plan to use this, I would love to see you add these in. So you can only fire 1 bullet at once, just because of the way it's written right now. The monsters don't move vertically, they do only move left and right, and they don't move very well. So it would be very nice if you can add it so they kind of come down at you. The monsters don't shoot anything, so it's really, there's no challenge to this game at all. There are only 10 monsters, no challenge as well. And the sprites are just blocks, so if you want to find better animations, please do. So that is C Natural in a nutshell, I think. Does anybody have any questions? Can
Wonderful.
be
Thank you very much.
Anything. Yeah. Cool.
Put together nicely.
Yeah. We can give it 5 minutes.
Yeah, I don't know. If anyone has any questions, again, you can shoot us an email. Please, if you got anything at all that you want to say, just either send us an email or open an issue, a pull request, anything on the GitLab. Because
it doesn't even have to be, I guess, an issue or something wrong with it. If there is something you want added, then please tell us and we can add it. We kind of want this to be an actual usable language. So we do need more than just two people's opinion on what makes a language usable.
Exactly.
I mean, the first thing I can come up with that I want to add is kind of a destructive tool so that it can remove all of these C++ files that have now been generated, because it turns into quite a lot.
That's what make clean is for.
Yeah, but that only does the last one. So I would like to remove all of them if possible. But that's just a very minor thing. But as a whole, this language is usable. This language works, and you can use it to do almost anything you would do in C++. Almost.
Almost. We're getting there. Eventually, it will just be C++ with less syntax.
Eventually, we're going to take over C++. That is another thing. If you already have C++ code that you like, you don't want to change, you can write C natural files and then link it to those C++ files. They are compatible with each other. And you can, well, C natural is compatible with C++. C++ can be used with C natural. So that is kind of another feature, I guess, just to clarify.
Yeah, that's a good question from Jimmy there.
It's essential.
In C++, indents are not at all relevant. White space is basically completely ignored for most of the syntax, and all of the scope information is contained within the curly brackets. We just add indentation for readability. We take more of a Python approach to scoping. So you can use any indentation you want. So you could have 3 spaces, 2 spaces, you could use tab, you could not use tabs. But as Python does, that indentation, although it is white space, it also contains all of the scope information. So it has semantic meaning now. So yeah, indentation is important. Similarly to Python, if you don't use consistent indentation, it doesn't know what scope level you're on. So it will be a syntax error to use inconsistent indentation, yeah.
Yeah, just to add on to that, whilst you can have any indentation number that you want, you can use 1 space, 2 space, whatever. Currently, the LSP does only register 4 spaces, so it will keep coming up with errors for more than that. That is purely because my programming style is 4 spaces. But again, that is on my to-do list to fix in the near future.
Yeah, so if that's all of our questions, unless Kieran has anything to add, I think that's all from us.
Yeah, thank you for spending 45 minutes of your life watching us. We're very grateful for the views.
No, thank you very much.
Okay, thank you.